Okay, here we go. Second try. Take this number n and suppose it has a factorization into a bunch of prime p's. And that it also has a factorization into a bunch of prime q's, where there might be k p's and there might be m of the q's. Let's insist, possibly with some relabeling, that the primes come in order as we did in class. This part was clear, I think, that taking this first prime, p1, which is necessarily the smallest, it has to divide, it's a factor of n, so it must divide the product of all the q's, which is just n. That means that p1 has to divide one of the q's, but since the q's are all prime, then p1 in fact has to be one of the q's. Okay, so p1 has to be one of the q's. Let's call it q sub I. And what I didn't do in class, what I'm doing now is I'm introducing a color scheme where everywhere these two appear, I'm just putting a green circle around them. Okay, and now the goal was to show that p1 in fact has to be q1. But the argument is kind of either obvious or subtle or something, so let's do it. If p1 is not q1, well, then I can repeat the same logic with respect to q1. What is q1? It's one of the factors of n, so it divides n, clearly. So if it divides n, then it must divide the product of all the p's, since that is n. But if it divides the product of all the p's, then since it's prime, by the prime divisibility property, it has to divide one of the p's. Let's call it p sub j. So now everywhere where q1 is p sub j. Okay, and now for the first time, I use the fact that p1 is not q1. Okay, since p1 is not q1, now I know that the green and the red are like different from each other. Well, how are they different? Well, and maybe it's worth mentioning that, okay, if the p1 and the q1 are different, another name for p1 is qi. Well, that means that, so in other words, since q1 and pj rather are the same, this is just me repeating this line, and p1 is not q1, then p1 is not pj. Here I just, well, there it is. Okay, and if p1 is not pj, then based on the way I ordered the p's, p1 in fact has to be less than pj, because I listed the p's in increasing order. And it's possible that p1 equals p2, but only if they're the same. So once I establish that these p's in fact have a different value, then in fact p1, the one with the lower index, must be smaller. Okay, so that says that the green is less than the red. And that is depicted here. Again, you can just see by looking at the p's that the one with the lower index has to be less than or equal to the value of the one with the higher index. But in fact, in this case, strictly less than, because we know they're not the same, because that's my assumption, which is that p1 is not q1. And in fact, pj is q1. But then you just turn the same argument around. You say, okay, well, once again now, since p1 is not q1, now I use the fact that p1 actually has this other identity as q sub I. And if p1 is q sub I, then it means that q1 is not q sub I. But if q1 is not q sub I, then also since we put the q's in order, q1 must be the smaller one. So following the sort of identity of of p1 as qi, since its index is larger, then q1 must be less than qi by the ordering of the q's. Okay, and here we have this sort of a visual contradiction, right? These two greens are the same. What's qi? It's where p1 appears in the list of q's. What's pj? It's where q1 appears in the list of the p's. On the assumption that p1 and p2 are not equal, then you have this kind of arrangement in which green is less than red, but also red is less than green, which is impossible. If you want to just see that one more time, we can do sort of one more substitution where we say, that this p1 green is less than q1 because q1 is just pj. But over here we get that q1 red is less than this p1 which is green. And so now we have just a straight contradiction that says that p1 and q1 have opposite relationships. Conclusion is that we have a contradiction, and so our assumption that p1 and q1 were different is false. In fact, p1 equals q1, and so you can peel them off repeat the logic, and in fact, every one of these factors just has to be the same all the way through to the end. Okay, hopefully that was helpful to some people. Goodbye.